Hello, Professor. It's Stepan, one of your students. All right, you know me. So I'll give you an introduction to my project. These are the business requirements. I wrote them for myself to understand more deep the overall requirements and what I have to write in my code. So this is not really important, but I'll guide you through this real quick. And firstly, let's start with the overall idea. I wanted to actually get to know how the systems worked back in the days in 70s, 60s. How the I know the Java was not there, but let's assume that we had Java back then, and I want to check how the files were actually executed within the operating system. So let's assume we have a. By the way, the system is one CPU, one core, one thread. So I'm sorry for that, but I had to keep it simple because I had major problems with C, was pointers and all that stuff. So my bad for that. But anyways, let's assume we can have multiple files, meaning multiple processes, because each file will be converted to a process because it has to have its arrival time, execution time, all that sort of stuff. So, but for now, you can check it out in the code because you will have the CLI, everything will be visualized and it will be nice and neat. So you don't have to worry about that. But for now, let's stick to the one file, one process because it will be a quick walkthrough for my project. So we're having one test file, test one.java. We're having this file. It's then converted to a process, PCB, TCB, all that stuff is not taking place. Process, unit of execution. It turns to a unit of execution. All right, it's in the new state because it's just a newly created process, obviously. Then before memory is allocated, it's in a new process. Then the memory is allocated. It goes to a ready queue immediately. Immediately goes to round robin and memory manager. The real deal happens. It goes into RAM with memory manager. Memory manager will be very strict. It will have four strict partitions, strict memory allocation. The round robin treats all the processes fairly, very fairly, because it has its own quantum time, which is, for example, 2. Let's put it this way. For example, 2 in each process, if we had multiple files, meaning multiple processes, each file, each process would get only, for example, two units of time. Yes, and yeah, pretty much that's it. I mean, simple algorithm, simple memory manager. Yeah, I just the interesting part was coding for me, mostly, and understanding more deeply. Now that I've done this, it looks just more easy and pretty much understandable for me. I don't really know how to explain, but whatever. Yes, the process goes through round robin and through memory manager. If process is done, it goes to finish state, and if process is not done, it goes back to queue and proceeds to execute again. And if we had other processes, these processes would be executed firstly. I mean, after, if this one is placed there, you understand. Of course, you understand. You're the best. Yeah, I don't even have to explain it to you, but yeah, pretty much that's it. Now I will show you how the how the code works. You just get it from GitHub. You go to CRC, you compile it. Oh my bad. What's it? My bad. I'm extremely nervous. What's going on? And you just start the main, the CLI. You enter the total memory of the system. You can put anything. Also, please, I want you to check out the documentation. I actually want you to give me a thorough feedback on documentation and the documentation in the code, the comments. So please give a feedback on that. Please, please, please. I didn't really focus on the code, but I want you to really check the documentation because I want to know which like what can I improve in my documentation, because documentation is actually the real deal. It is the important part. The code is you can copy paste, it's fine. But the documentation, if you mess it up, it's gone. The code is gone, everything's gone. The documentation is important. So please check it. Very important. Anyways, going back to the project and the CLI, you'll have to enter the total memory for the system, quantum of time for a single process. Let's put it like 2. You can try many different things. I think it's quite safe. If from a logical perspective, let's not put anything crazy, please. Because yeah, the cases are not very developed in here. That's one of the improvements I can make. But hopefully, I'll make the system in C and more thoroughly with system calls and all that sort of stuff. number of files, let's just put one, and then you will have to put as for file a name. Let's put it test1.java. Anyways, it will still work with the anyway size 120, meaning we can fit into partition, because one partition will be 1200 divided by 4 will be 300, so we're fine. The memory will be allocated for the process. And please also put the memory within the size, because if you put more, it's not going to be executed, it's going to be an infinite loop. Yeah. And arrival time, let's put 0. Execution time 2. Yeah, everything is simulated, you can try it out. Size set address, it has the addresses occupied by process 1, as you see. Just 2 units for the process and 2 units for the round robin, which is going to be quite fair. And you see total memory is 300, which is a strict partition. Turnaround time, everything is nice and neat. Please, once again, please check out the documentation and the comments in the code and the code itself. That's it. Easy compilation, easy start. Thank you very much, Professor. I wish you all the best. It was a great interesting topics we discussed in the classes. So yes, I believe, thank you. You gave me a great foundation. I believe, I hope I sold the idea nicely. You're not gonna fail me. Yes, thank you again.
Hello, Professor. It's Stepan, one of your students. All right, you know me. So